So you are installing this 1/2 inch diameter braided stainless steel water supply line for a kitchen faucet, and you have to go through the cabinet's gable with this 1/2 inch line. How big of a hole should you be drilling? Obviously large enough, but hey, let's do some thinking. This is a 1/2 inch line. We know this, the packaging says so, and measurement confirms that this is indeed 1/2 inch in diameter. So will the 1/2 inch hole be enough? Obviously not, because you forgot the fitting. There's a fitting at the end of it. Of course, you're a clever one. You know this is a 5/8 fitting because the 5/8 wrench fits on it. You've tightened this before. So the 1/2 inch hole is not good enough. The 5/8 should work, yeah, but it doesn't. We have a situation. Obviously, you go to the next drill bit size, 1/2 inch, 5/8, 3/4, and alas, that one is big enough for the 1/2 inch line to go through. So the correct answer is 3/4 inch, except once you drill a hole this big, you can't drill through the same, you can't drill this bigger. You have to be cheese holing it, and that's not cool. You have to know which size of hole to drill for the 1/2 inch line before you start cheese making. So do the math on a computer screen. So what size of hole should be drilled for a 5/8 hexagon? Well, the hexagon is right here at the end of the fitting, looking like that. And for a 5/8 hexagon, a 5/8 hole obviously doesn't work. Why doesn't? Because a hexagon from side to side is shorter than from corner to corner. How would I know that? Well, what we have here is a situation in geometry that's called a circle inscribed hexagon. If you make this 5/8 side to flat side measurement, and you make it into a circle whose diameter is exactly this 5/8, it's immediately obvious that the corners of the hexagon are extending past the circle. It just, the 5/8 circle fits inside a hexagon, not to the outside of it. So how big is the hole that we need to drill? Well, what we have here is a reversal of this situation. We need the hexagon to be inscribed a circle. The blue circle is what we need to drill, and obviously the 5/8 white circle is not going to be the answer. Can we calculate the size of the blue circle given that the hexagon is 5/8 from flat side to flat side? Of course we can. How would we go about that? Well, the hexagon needs to be broken up into little triangles like this. Right angle triangles can be calculated. Now the hexagon breaks up into 6 triangles, 6 equilateral triangles, or 12 of these right angle triangles. And it was 5/8 from side to side, but now the radius of this 5/8 diameter circle, the white circle, now is going to be a little shorter. It's not 5/8. We're calculating this triangle here that I have just copied out from there, and it's 5/16 of an inch, because 5/16 is half of 5/8, because this is 5/8 for the diameter, so the radius is 5/16. Just math. We're going to use the cosine function because this angle here is known. How do we know that angle? Well, 360 degrees make the full circle, and we have 12 of these little triangles. 360 divided by 12 will be 30. So then, we enter the numbers in the calculator based on this SOHCAHTOA. So the cosine of an angle is adjacent over hypotenuse. Solving it for hypotenuse, because we need the circle's radius from the center to the long point of this hexagon, which is longer than 5/16. So 5/16 divided by cosine 30, 5/16 in decimal is that number, cosine 30 is that number plus spare digits because there's more, and that's the number that appears on the display of the calculator when you enter everything. Remember, this is radius. So for the diameter, you need to double it because the drill bits are diameters. So then, if we double the radius, we get diameter. I just wrote the digits down from the calculator's display. And this is nice decimal inches. We need to convert it to some kind of fraction so we can find the drill bit on a fractional drill bit set. Well, if we can approximate it into 128, nobody makes that size of a drill bit, maybe 64th, yes. But eventually it's gonna round down to 23/32 of an inch-ish, but that's undersized by a smidge. So if you convert 23 divided by 32, you look at that decimal number, whatever that's gonna get you, it's a little less than that. Which means that your hexagon, the fitting is, the hexagon will still not fit by a hair at the corners, because that 23/32 is a hair undersized. You're gonna have to go up to the next size, which is 3/4 of an inch. And however massive this 3/4 inch hole looks like, you can see there is quite a bit of spare room around it. That is just the correct answer or correct drill bit size to choose for this drilling operation. And yes, you can just drill test holes in a piece of wood, and you don't have to do all this math, obviously. But you do have to pick the right drill bit size before you start Swiss cheesing a cabinet gable. Now, this same math works for metric sizes. Of course, these holes could be 10, 20, 30, or 10, 15, 20 millimeters, whatever. The same logic and the same math applies. I'm not saying that I'm converting the 1/2 inch to 10 millimeters or whatever. This is not a conversion. I'm just picking easy numbers in metric to illustrate this problem here. Same point. So I picked 10 for the radius, so from the center of the circle to the edge of the white circle there, it's 10 millimeters, or 20 millimeters from flat side to flat side on the orange hexagon. So how big is the circle that we need, the blue one, to fit the hexagon through? Exactly the same math applies, just plug in 10, and for the hypotenuse here, or the radius of the blue circle, we get here 11.5 plus change millimeters. Double this and we get 23 millimeters plus change. And that plus change means that you cannot drill a 23 millimeter hole because that's going to be undersized. You have to go bigger. Good luck finding a 23.09 millimeter drill bit. That's not happening. So obviously you're going to have to go to the next larger sensible drill bit size, whatever, 24 millimeters, or its inch-based equivalent, whatever. So you can't go less than this number. Exactly the same problem as with this figure here. If it's undersized, it's not going to work. It has to be oversized with little bits of gaps here between the side walls of the hole and the corners of the hexagon. So that's how the math works. And obviously, you don't have to do the math on the job. You just have to drill the one hole that works for your fittings to get the hose through.